everybody. Hopefully you managed to have some great conversations in the lounge and managed to get around some of the exhibition booths during the break. So welcome back to the main stage, and this is the first in 2 sessions of some parallel sessions, and we're really pleased to welcome Helena Dodd to talk to us about perfect practice. Thanks, Helena.
Hi everyone, thanks for having me today. I'm going to talk to you about pursuing research and what it's like doing a career in engineering research. So I have a PowerPoint presentation to show you. Hopefully you'll be able to see that. So during my talk, I'm going to talk to you for about 20 minutes. Please do feel free to write questions in the chat. Unfortunately, I won't be able to see them while I'm presenting, but at the end, there's about 10 minutes where I will be able to see your questions, answer them, and you can also, of course, wait until after I've given the talk to ask questions. So my name's Helena. Thank you, Susan, for the introduction. I'm currently doing a PhD, in fact, finishing up a PhD. I'm in my final year in biomaterials engineering at Imperial College London. And I'm also affiliated to the Institute of Chemical Biology Centre for Doctoral Training at Imperial. So I thought I'd give you a brief background on my background before starting my PhD, so that you know the kind of previous academic qualifications and experiences that I have. So I did A-levels in chemistry, maths, biology, and Spanish with an additional AS level in music. I was born in Berlin, then grew up in Mallorca in Spain, and I moved to the UK for my A-levels. Then I did an undergraduate degree in chemistry at the University of Birmingham. This was an MSci, which is the equivalent to an MEng, but in science. And after doing my undergraduate, I decided I wanted to move to something a bit more technical, more engineering based, a bit more problem solving-y. So I moved to Imperial, where I'm currently, as I mentioned, I'm on a program called the Centre for Doctoral Training in Chemical Biology, where I'm focusing on biomaterials engineering research. This is a 4-year program. So I'm in my 4th year now, started 3 years ago, and after the first year I got an additional master's, fully funded, which is an MRes, so Masters in Research. That's why I have 2 master's degrees. I will talk a bit later on about what a CDT is, how the structure of this is different to a PhD in the more traditional sense, and what the qualifications look like, the assessments, things like that. So as well as being at Imperial doing my PhD, I am also the chair of the Women in STEM at Imperial Network, which is the WES affiliated student group. And through that, I joined the UGB, which is the WES University Groups Board, which I would highly recommend if any of you are involved in your student groups, please check them out. They do some amazing work, and it's a great way to gain some experience, not only on a WES board and working, volunteering with a national charity, but also to network with other student groups and collaborate on events. Prior to that, during my MSci, I started my work in women engineering groups by chairing WISE, which is Women in Science and Engineering. So here's a brief kind of summary of the things that I'll discuss today. So I've already given a short introduction on my background. So I thought I'd then move on to kind of a bit of a broader sense of what is the academic research career pathway like. So if you want to be a researcher, what does the career progression look like and how does it work? How do you get into it? What are the different steps? Then I'll discuss a bit how PhDs work in the UK, because I know it can be quite daunting. If you don't know anyone personally who's done a PhD, it can be a bit intimidating. There's a lot of information out there. It's hard to know where to start and how to gain an insight and information in how they work, what the application process is like, and what they're looking for. So I'll break that down into 3 different sections. So firstly, different types of PhD programs, you know, what's available in the UK, what's the difference between them, how the funding works. So do you get paid when doing a PhD? how much, how does it work? Does this vary depending on the PhD program, and how the assessment works? So a PhD is a very different kind of degree to an undergraduate degree. So for example, an MN or a BN or even a master's, and I'll talk about that a bit more. Then I'll give you some background on me and particularly my research experiences. So I've outlined briefly kind of my academic qualifications, but I'll talk a bit about specific research projects I've been involved in, how they've led towards doing my PhD now, what my research is like, and additional things that I do as a PhD student. So as well as the research, what else do I do? So I thought this could be a nice way to give you an insight on kind of what the day-to-day is like, and kind of so that you can see the breadth and also depth of things that I get up to. And then, as I said, there'll be time for questions at the end. So what is the academic research career pathway like? So you start with an undergraduate degree, which I'm guessing is what most of you are doing now. And then the next step, if you want to be a researcher, and especially in academia, is to do a PhD. So in industry, there is options to join after your undergraduate degree to be a researcher there. However, if you want to do really technical roles and move up in to senior positions within technical roles, most companies will require either a PhD or quite extensive work experience. I'm sure you've all heard of graduate schemes. They tend to be geared towards management quite a bit. So depending on the type of industrial role you want, you will probably get exposed to quite different roles and experiences if you go in on a graduate scheme, or if you go in after a PhD or some work experience. That's not really my area of expertise since I'm at a university, but I do have quite a lot of friends who've done this sort of thing, and I myself have done some internships in industry. So if you have any questions about that, I'm happy to answer them later. So nowadays, unfortunately, PhDs are becoming more prevalent, so more people are aware of them, more people want to do them, so that's making them quite competitive. So because of that, it's now a requirement pretty much universally to have a master's degree if you want to apply for a PhD program. Some of them don't, and instead of a master's degree, you could have multiple years of professional experience. That's usually seen as fairly equivalent. But if you don't have a master's degree and you apply for a PhD position, you will be competing against people with a master's degree. So it's worth having a think, what else do I have? What strengths do I have that they might not have that I can put in my application in order to stand out? So after you do the PhD, if you then want to stay in academia as a researcher, then the next step is to be a postdoc. So in the US and other countries, they usually call this assistant lecturer, but here it's usually called a postdoctoral research fellow, or you might see PDRA or PDRF in some places. So usually in a postdoc, you join, you essentially do the same work as a PhD, but in much less time, because you're much more highly trained researcher, and you can come in, you don't have to write a thesis, you don't have any assessments, anything like that anymore. You're just focused on the research. Usually, if you want to move on to the next stage, which is a lecturer or a full fellowship, most people tend to do 2 postdocs, and each postdoc tends to be about 2 years long. So that's why I've said on average, you might be looking at 3 to 5 years of postdoctoral experience before moving on to a fellowship. So what is a fellowship or a lectureship? So this is usually the first time that you run your own research group. So you've spent a few years as a PhD student training and gaining that qualification. Then you've spent a few more years as a postdoc. Usually if people do 2 postdocs, they'll do them in 2 different places. So you'll gain insights in working in 2 different environments. It can be seen as quite favorable to do postdoc overseas. So maybe, have had experience of research in multiple countries by that point. So during a research fellowship or a junior lectureship, you've kind of already proven your ability as a researcher, and you get funding to essentially start your own lab. So these fellowships are usually funded not by universities directly, but by a charity or research council, which is government linked, or a learned society or something like that. So usually they're fixed terms, so they're for about 5 years quite often, and it's essentially to give you the time to start building up kind of your own research environment, to start training PhD students, postdocs, to start having people that join, and you then graduating them and having them leave and move on to other things. And once you've done that, if you've been successful, then quite often a university will hire you permanently. So it's also worth mentioning that during a fellowship or a junior lectureship, even though you're funded by someone external, so for example, a charity, you quite often need to have a university to agree to host you. So they essentially give you the space of the lab, they give you an office, they give you teaching opportunities, but they don't pay you. You get your funding from your external source. So it's essentially a probation period where then if the university thinks you're doing good work, and if they think you're a good fit after that probation period, they then offer you a permanent position, which means kind of you don't need the external funding anymore. The university covers your salary. And this is quite often a permanent position. So then you have quite a lot of stability from then onwards. So when you're a senior lecturer, all the other steps above, so reader is essentially a middle road between senior lecturer and professor. I'm sure everyone here has heard of what a professor is. It's essentially a very senior, experienced lecturer. And then there's other kind of higher management roles, such as head of departments, faculty leads, deans, and then eventually vice chancellor, things like that, which not all academics choose to go down that route. Some are very happy just staying at professor or even lecturer level, running their own groups, and they'd rather focus on that as opposed to going into a more admin and management role. That's up to you. Both paths are options, so you could do one or the other. When you get to senior lecturer, if you do want to move up a bit further, then usually you need to do some additional teaching, being a personal tutor, and kind of contributing to university beyond what you do with your research group. So hopefully that was an introduction on how the academic career path looks like in the UK. So next, how do PhDs work? So firstly, there's a range of different types of PhD programs available. There's, you may have heard of EngDs, which are engineering doctorates versus PhDs. They're usually quite similar, but EngDs tend to have more industrial support, and they tend to be more kind of problem solving on kind of a short term, a quicker timescale, as opposed to PhDs, which can be quite high risk and sort of quite out there abstract work. There's also options to be either funded by industry or universities or research councils. For example, I'm funded by the Engineering and Physical Sciences Research Council. So this decision will affect the IP you're able to get out of your PhD. So if you're funded by industry, you might not be able to own any of the patents that you might put out. Whereas if you're funded by other sources, they might give you that option. It might also change the publications that you do and conferences that you speak at if you have IP clauses. It will also affect the exposure you're given. So if you're funded by industry, you might have access to more equipment, you might travel more. And also this could affect kind of your options after. So if you have an industry funded PhD, you're probably very set up, very well placed to do a senior industry job after your PhD, and you might have contacts with that, whereas it might be harder to move into that if you don't have that industry link, and also the opposite way. So if you're through a university, it might be easy to get a postdoc there, whereas if you want to go down an academic pathway, whereas if you're very tied to a company, it might be different. That depends on the situation. Then there's also programs called CDTs, so Centers for Doctoral Training, which are a relatively new type of PhD program that essentially is more structured. They're usually a bit longer, and they give you additional training courses. And also there's more of a cohort. So there's usually multiple people that join CDTs. So it can be a bit more friendly. You have other people going through the program at the same rate that you are. So then for funding, I've already briefly touched on industry-funded PhDs and that being an option. A big upside of them is they tend to be higher paid, and you usually get the chance to do a placement or a rotation or spend some time at the company that fund you. Research Council, I think in the UK, is the most standard funding source. And they're quite often linked to CDTs, and they will have limited places available each year. But they'll take usually more than one person each year, which is what I mentioned, where you get a cohort formed. Then there's university-funded PhD places, which can operate on quite a similar way to Research Council or CDT funded PhDs, but they're funded by the university. So I think they also try and have a cohort of various people. And usually this is supervisors or group leaders have had to go through a round of competing for funding to be able to offer you that place. There's also scholarship funded PhDs. So if you're not able to get funding via any of the methods above, then most universities will have scholarships available that you can apply for in order to get funding. There's usually very few of these, and it's usually incredibly competitive because usually the people that apply for these haven't been eligible for others, not because they're not incredible candidates, but usually, unfortunately, due to nationality restrictions or things like that, because quite often if you're an international student, it can be hard to get funded positions. So because of that, it's usually very, very competitive. So the other option, the final option, is to be self-funded, which involves paying your own fees and living costs without a stipend. There are other ways to get kind of really external funding. So if you're an international student, you might be able to get your home country government to give you some money. So the UK might class you as self-funded, but you may actually be receiving outside funding. There's also an option to start a PhD self-funded and then work with your supervisor to apply for money once you've started. That can be a bit risky though, and the success rates may vary. So assessment processes. PhDs have no grades. You do not get a degree classification at the end. It's essentially pass-fail. I personally think of a PhD as being more like work experience, more like a graduate scheme, but just doing really intense research, as opposed to a degree like your undergraduate degree. Usually the assessment process is you might have a few sort of progress reviews. So Imperial has, for example, an early stage assessment in your first year, and then a late stage review in your second year. And then at the end, you will have to submit a thesis, which is usually book length. It's very long, it's usually 200 plus pages. And then you'll have an oral examination called a viva, where two experts in your research field will question you on everything you've done, and you'll have a discussion with them. And if that goes well, then you officially pass the PhD or the MD and you get to use the doctor title. So no PhD project is the same. And also different universities have assessment processes in different ways. So don't compare yourself to other people that you know that might be doing a PhD. Each project is different. Various factors will affect your outputs, so publications, conference presentations, things like that. So just because someone else is doing something doesn't mean that you should be doing that as well. And also alongside the PhD, there's usually quite a few opportunities to do some teaching experience. Usually get paid extra money for this, some mentorship and things like that. And you might even be able to get accreditation and qualifications for that. So my academic background, I'll give you a very quick kind of overview of this. So before I did the PhD, I knew I was interested in research, but I wanted to explore different options to see the kind of research that I like the most. So I started in my first year of university doing a teaching internship. That was my first teaching experience. Then the following year, I thought I want to give industry a go, see how that compares to academia. So I did an R&D internship at Unilever, where I was helping produce and engineer new products for their refreshment, so tea and ice cream. Then the following year, I thought, right, I've done an academic, quite sciencey internship. Now I want to do, I've done an industry internship. Now I want to do an academic, proper research one that's not teaching, that's more lab-based. So I did one in sustainable materials chemistry. I really enjoyed that. But then I thought for my master's, I'd like to specialize a bit more in synthetic organic chemistry, which is a different type of chemistry, because I thought I wanted to do more medicinal things and drug discovery. So I did that, and then that led me on to my PhD project, which is essentially combining my master's project and research project, the summer research project that I did. So it's really interdisciplinary. I'm essentially engineering new nanomaterials based on graphene oxide, to make them activate our immune cells to be better at killing cancer cells. So this is the kind of engineering that I do. So I take graphene oxide, which is number one here, and then I do lots of synthesis and engineering onto it to make it into a much more complex thing that is able to bind to cells. And I focus on a type of immune cell called a natural killer cell. I use a lot of engineering techniques to characterize the nanomaterials that I make. Is very important before I test them that I know that I've made the thing I wanted to make. So here's an example of some of the range of techniques that I get to use on a weekly basis. I really like, one thing I really like about interdisciplinary research like mine is I get exposed to a huge range of techniques, which is really nice. So I use some microscopy, but also some other more bulk techniques, such as dynamic light scattering, which tells you the size of nanoparticles. Then I move on to testing. So this is kind of what some outputs look like of some of my cell experiments, where I can look at how my nanoparticles bind to cells. So these plots are from a technique called flow cytometry, where every single dot is a cell. So hopefully you can see there's a shift of a population when they bind to my nanoparticles. Here's just a schematic to show how my nanoparticles are tiny compared to a cell. So lots of them combined at once. And then I can also measure killing. So once I've bound my nanoparticles to cells, do they make these immune cells kill cancer cells better? And hopefully you can see here, this is just looking at ratios of different types of cancer cells and seeing if more of them are killed when I use my nanomaterials. So outside of my PhD, there are some additional things I do. I'm not going to talk about this too much in detail. It's just to show you the range of things that I can do. So I'm really passionate about outreach and equality and diversity work. So getting more women into engineering. So I do a lot of work on that, lots of volunteering, lots of outreach. And I also do quite a lot of mentoring because I think it's very important to support the next generation of especially women research engineers. And I don't do it for the recognition, but it is quite nice that now that I've had a few years of doing things, I kind of get more opportunities come along the more that I do, and I get some recognition for it, which is really nice. So that's it for my talk. I hope you enjoyed that. I hope maybe you found it interesting and learned a few things. So I will now take some questions if there are any. And here I thought I'd end on this slide, which is a friend of mine who is on my same cohort of my CDT, did some artwork for me to illustrate the type of immune cells and cancer cells that I work with. So I will stop sharing my screen. And Susan, are there any questions? I think you're on mute.
Classic. But thank you. Yes, I'm back. Thank you. That was brilliant, really interesting for someone who's not in academia to hear how it all works. And I'm sure people on here who are interested in pursuing that have found that super useful. There's lots of good practical advice in there. Definitely always take the accolades. I know you said you don't do it for that, but always toot your own horn, I would say. So if anyone here has got questions for Helena, please do type them into the chat. Before they come in, I just wanted to draw you there. You said you're not going to talk too much about your voluntary work, but I wonder if you wouldn't mind just sort of sharing with people the value that you've got from doing things like being on the board of the UGB at WES. You know, what sort of opportunities maybe doing that alongside your PhD have opened up that maybe doing your PhD wouldn't have given you?
Yes, absolutely. So I think doing a PhD, especially in academia, a lot of the people that I interact with are all doing the same sort of thing. It can feel like quite a closed bubble. And I think it's very important to still kind of do some engineering outreach and work with communities outside of the small communities that I'm a part of, because it really helps kind of put the research into context. And I think it's very important, especially when those of us whose research is publicly funded, so I'm funded by a research council, which is government linked. I think it's really important to have constant reminders that what I'm doing is important and that general public and people outside of academia should know what I'm doing. I kind of owe it to them to update them and for them to know where their money is going. So being a part of the UGB and boards and voluntary organizations is a great way to work with other STEM organizations that have a different viewpoint to academia. And it's also really interesting to kind of, I think my work is better by getting outside input. I think people from different backgrounds have a lot to offer, and I think diversity of viewpoints and of experiences is really important to further engineering research. I think in order for something to be able to benefit the public, it's important to have the public involved, isn't it?
Yeah.
Public needs, and to make sure that they know if you're delivering. I think it has to be a two-way street, and it's important to gain feedback from what you're doing to make sure that you're meeting the needs that you think that there is.
Yeah, great. Good. We've got a question from Jess here, who's asking whether you should you choose to do your PhD based on the uni prestige? I suppose she's maybe aiming this question at your point that, you know, if you want to get certain jobs, PhD is a must. So do you go for uni prestige or do you go for the topic?
I would say topic first. I would say I know we've all seen league tables, we probably all hate them. League tables don't exist for PhDs though, however, because you should go by the research. Find someone who's doing research that you find really interesting. Yeah, I guess prestige does play a part, unfortunately. However, the part that plays usually isn't the reputation of the degree you get. A PhD is a PhD from wherever it is. It's more it affects more the facilities you'll have access to. So how much money there is, how much equipment the university has. So I would say base it more on that. So topic first, and then have a think. Does this university have the facilities to support this topic I want to explore? And if it doesn't, then maybe a different university might be better, or industry, or a different partnership.
Yeah. And probably especially in, what you're working in is, people are looking for people who know their stuff. So it's about the topic. Yeah, exactly.
Absolutely. Yeah.
Great. Well, we're almost out of time. So I'd just like to say thank you so much, Helena. Thank you for everything you do for WES. We appreciate it. And our members appreciate it. So thank you. And thank you for talking to us today. I noticed at the end you put your email address up. Are you
I'm just typing it into the chat now. Yes.
So that's great. Perfect. So Helena's popped that in the chat there. So if you do want to get in touch with Helena, you're happy to answer questions. So encourage people to network and get in touch with Helena if you have questions that we haven't been able to answer on here because of time.
Yeah.
Just a reminder, so thank you, Helena. Just a reminder, the next session is at 1:05. And again, there's 3 sessions for you to choose between: making the most of mentoring, work-life balance and working part-time, and then preparing CVs and job applications. So do have a look at the agenda, have a look at the speakers, and go to the right room. If I don't see you in the next session, I'll see you back at the closing session at the end of the conference. Thank you, everyone. Bye-bye.